Hello students, in this video we are going to discuss about the oxidation number in the chapter Redox reactions. Oxidation number, it is defined as the charge which an atom appears to have when all the other atoms are removed from it as ion. That means oxidation number is nothing but the charge on the atom when all the other atoms present in that molecule is removed as a ion. When we take an example of a HCl, if we want to find out the oxidation number of Cl in HCl, here it have another atom here, that is hydrogen. So when the hydrogen with one positive charge, that is hydrogen ion, is removed from this, so what will be the charge developed on the Cl here? Because the whole molecule is actually a neutral, from this one of the positively charged species, that is when the H plus is removed. So what it develops in here? It develops a negative charge, that is on the Cl. So what is the oxidation number of Cl here? That is -1, because the hydrogen having +1 charge. So what will be the oxidation number for Cl here? -1. So the oxidation number is defined as the charge. This number is nothing but the charge which an atom appears when all the other atoms, like in this hydrogen, is removed as an ion. When it is removed as an ion, that means when it is removed as H positive, then what will be the charge on Cl? That is Cl minus. That is -1 charge. So the oxidation number for Cl here, it is -1. So in order to find out the oxidation number for the any particular element in a given compound, so for that we need to remember some of the rules which we need to follow. First one, the elements in their elemental or uncombined state have an oxidation number of 0. That means if any element is present in the uncombined state like He, helium, Fe, iron, sulfur, these are in the uncombined state or in the elemental state, here the oxidation number for all these is 0. And when there is a molecule that is a dimolecular, bimolecular, that means it having the molecular in which the same atoms are forming the molecule, that is homonuclear molecules. In that case also the oxidation number is equal to 0. That means O2 is a homonuclear diatomic molecule. Homo means because here two oxygen, that means two similar atoms are combining to form a molecule, oxygen molecule. That is called as homonuclear diatomic molecule. Similarly, N2, here also the oxidation state for N is 0. For Cl, in the oxidation state for Cl2 is 0. And the oxidation state of O in O3 is also equal to 0. What about the case of oxidation state of P, that is phosphorus, in the tetraatomic form? That is also equal to 0. The oxidation number is equal to 0. So the oxidation number is 0 for the elements which is there in the elemental or the uncombined state. They having the oxidation state 0. So here these are the example, and one more example I can add here, that is S8. In S8 also the oxidation state of sulfur is 0. In the case of sodium, magnesium, aluminium, silicon, these all are the in the elemental state. So these all are in the uncombined state, they having the oxidation number equal to 0. That is the first point says. Second point, the oxidation number of a monoatomic ion is same as the charge of the ion. That means what will be the oxidation number for an ion, and which type of ion? It should be monoatomic, like magnesium ion. magnesium ion. What is the charge on the magnesium ion? That is plus 2. So plus 2 is the oxidation number for the magnesium ion. But remember here, for the magnesium atom, that is in the elemental state, the oxidation number is equal to 0. But for the magnesium ion, the oxidation number is equal to plus 2. What about the case of sodium ion? For sodium ion, it having one positive charge, that means the oxidation number for this is equal to plus 1. That is for sodium ion. But for the sodium, the oxidation number is equal to 0. But for the sodium ion, the oxidation number is equal to its charge. And what is the charge of sodium ion? That is plus 1. Similarly, in the case of chloride ion, there is one negative charge, so the oxidation number is minus 1. For the copper ion, that is having two positive charge, the oxidation number is equal to, that is for copper ion, the oxidation number is equal to its charge, that is plus 2. So the oxidation number for a monoatomic ion is same as that the charge which is present on that ion. But when we take the case of hydroxide ion, OH negative, in that case we cannot take the same rule we cannot apply, because this is not a monoatomic, it is a polyatomic ion. So this rule is only for the case of a monoatomic ion. That means like this, when there is a single atom having a charge, that is called as monoatomic ion. The other ions like carbonate ion, CO3 2 minus, this is polyatomic ion. Sulfate ion, SO4 2 minus, that is a polyatomic ion. So this rule is not followed for these one. It is only followed for that ions which having single atom with a charge. Next rule says that for the hydrogen, usually the oxidation number is plus 1. Plus 1 is the very common oxidation number for hydrogen. In the case of HCl, what is the oxidation number of H? That is plus 1. And the oxidation number for Cl is minus 1. That we have already discussed. But except in the case of metal hydrides, when there is a hydrogen combination with the strongly electropositive elements like sodium, magnesium, in that case that means in that case the hydrogen will having the negative oxidation state, that is the oxidation state for hydrogen in that case is minus 1. So in the example NaH, that is the sodium hydride. Here sodium hydride, in which the sodium is of the group first member, which always develop a plus 1 oxidation state, as we have already discussed. So in that case, in order to be a neutral molecule, if one having a positive charge, the other must have the negative charge. So what will be the negative, what will be the minus 1 charge will be the for hydrogen in the case of metal hydride. So hydrogen usually exhibit plus 1 oxidation state, except in the case of metal hydride where it exhibit minus 1 oxidation state. That means the oxidation number is minus 1. Next is the oxidation number for oxygen is usually minus 2. That is, it is in most of the compound the oxidation number for oxygen is minus 2. Like in the case of water. In the case of water, what is the oxidation number for O here? That is minus 2. But in the case of peroxides are the compounds which having OO linkage, that is H2O2, that is hydrogen peroxide. It can be written as HOOH. Here there is OO linkage, that is called as peroxide. So in peroxide, the oxidation state or the oxidation number for the oxygen is not minus 2, it is minus 1. So that is important. In oxides, the oxidation number for the oxygen is minus 2, but in peroxides the oxidation number for oxygen is -1. So this also you need to remember in order to calculate the oxidation number. But in the case of halogens, they usually exhibit -1 oxidation state. Halogens means the group 17 members exhibit -1 oxidation state. Which are the members of halogen? That is fluorine, chlorine, bromine, iodine. These are the members of halogen. Usually these are exhibiting -1 oxidation state in the different compounds. But it can also exhibit it can also exhibit +1, +3, +5 and +7 oxidation state. That is in the case of the compound which is called as interhalogen compounds. The compounds, that means the compound between halogen and halogen is called as interhalogen compound. That means the compound between two different halogens are called as interhalogen compound. For example, CLF, BRF, BRCL, ICL, IBR. CLF3, BRF3, ICL3, BRF5, IF7, IF5, IF7. So these are called as interhalogen compound because here these are the compounds, that is the compound between the two different halogens. You are familiar with the example IF7. We have already learned the structure for this IF7. Here I is also the member of group 17, F is also the member of group 17. So such type of compounds are called as interhalogen compounds. So in the interhalogen compounds, the oxidation number for one of the halogen will be +1, +3, +5 or +7. That is, in the case of halogens, fluorine always exhibit -1 oxidation state. That is important point because fluorine is the most electronegative element. Therefore, it always exhibit -1 oxidation state. But the other halogens can also exhibit +1, +3, +5 and +7 oxidation state or the oxidation number. So, in the case of CLF, here what is the oxidation number for the fluorine? That we have already discussed because fluorine always exhibit -1 oxidation state. So what will be the oxidation state for the chlorine? That is, if fluorine having -1 oxidation state, it must be +1 for the Cl. That's why the molecule of CLF is neutral, because as the molecule is neutral, so the sum of their charges must be equal to 0. So here F is -1, having -1 oxidation number, so Cl having +1. So in the case of BRF, Br having +1. In the case of BRCl, Br having +1, Cl have -1. And when we talk about the molecule like ClF3, in ClF3, what is the oxidation state for F? That when we write the oxidation state for the case of Cl, in the case of ClF3, the molecule is ClF3. Here the oxidation state for F is -1. So what is the oxidation state for Cl? That will be +3. So +3 is the oxidation state for the case of Cl in the ClF3. So how the molecule will be equal to neutral? That is, because here only one Cl is there, so +3 is the charge on one Cl, and plus -1 is the oxidation state of F. And how much F are there here? 3 F are there. So into 3, so that is equal to +3 minus 3, that is equal to 0. That's why this molecule is neutral because the overall charge is 0 here. So in the case of IF7, the oxidation state of I is +7. So from this table it is clear that the oxidation number for fluorine is always -1, and for the other halogen it can be +1, +3, +5, +7 according to the compound that is in the interhalogen compound. Now let us discuss the method to calculate the oxidation number of the one of the element in the molecule. First of all, let us do for H2S. We need to find out the oxidation number of underlined element in the molecule H2S. So here we need to find out the oxidation number of sulfur. Now what is the method which we need to follow in order to find out the oxidation number that we are discussing with this an example? Here first of all you need to write down the oxidation number for the underlined one, that is we need to find it out the oxidation number for sulfur, that let us keep it as X. So X is the oxidation number for sulfur. Let we are keeping X as the oxidation number for sulfur, that we need to find it out here. And what is the oxidation state of hydrogen? That we have learned that hydrogen is usually exhibiting +1 oxidation state, except in the case of metal hydride. But this is not a metal hydride. So what is the oxidation number for hydrogen here? That is +1. Now how we find it out? The oxidation number for sulfur, that is X, we need to find it out. What is the overall charge of this molecule? Because it is a neutral, that means the overall charge for this molecule is 0. So now how we calculate this one? So +1, that is the oxidation number for hydrogen, that is +1. And here hydrogen, 2 number of hydrogens are there, therefore we need to multiply with 2. So 1 into 2, just close the bracket, next plus. Next we need to move to the sulfur. Sulfur, because there is only one sulfur, and what is the oxidation number for sulfur? That is equal to X. So when we solve this one, what we get? 1 into 2 is equal to 2 plus, and here it is X. So that is equal to 0 because the overall charge is equal to 0. So what will be the X from here? So that is the X, that is equal to -2. So what is the oxidation state of sulfur here? That is X, we have find it out, that is -2. So -2 is the oxidation state or the oxidation number for sulfur in H2S. Next, we are taking the sulfate ion. We need to find out the oxidation number for sulfur in the sulfate ion. It is a polyatomic ion. So, the oxidation number for sulfur, let us keep it as X, that we need to find it out. X is the oxidation state for sulfate ion, that is we need to keep it on it. So I will write once again here. The oxidation state for the sulfate ion is taken as X, and we know that the oxidation number for the oxygen, that is in the oxide state, this is in the oxide state, therefore the oxidation number for O is -2. Now how we calculated the oxidation state here? Because the overall charge here, it is given the overall charge for this molecule, as it is having the -2 charge, this is the overall charge of sulfate ion. So in that case, how we do this one? That is, here we need to take first of all X. Here only one number of sulfur is there, therefore X into 1 plus. Next, oxygen. What is the oxidation state for oxygen? That is -2, that we have written here with green. That is the individual oxidation state -2. But how many number of oxygens are here? In this ion, that is 4 oxygens are there. Therefore, into 4 we need to do, and that is equal to, what is the overall charge for this one? That is -2, as it is given. The overall charge for the sulfate ion is -2, that is equal to -2. So when you solve this one, that is x, and -2 into 4, that is -8, that is equal to -2. So when you solve this one, what you will be getting? That we will be getting x is equal to, that is -2 plus 8, that is equal to 6. So what will be the x? X is equal to plus 6. So here the oxidation state for the sulfur, that we have find it out here. What is the oxidation state for sulfur here? That is x is equal to 6. So 6 is the oxidation number for sulfur in the sulfate ion. Next, we are taking an example of chlorate ion. In the case of chlorate ion, here we need to find out the oxidation number for Cl, that is the underlined one. We have to find it out. We are keeping it as x. So let x is the oxidation number for Cl. And for the oxygen, -2 is the oxidation state for oxygen. Now we'll find it out the oxidation state for Cl by this method. That is x is equal to, that is here we are taking x. X is the Cl, and only one number of Cl are there. Therefore we have to multiply with 1. So 1 into x plus, next oxygen, -2 is the oxidation state of oxygen, that is written here with the green pen. And what is the number of oxygen here? Because 3 number of oxygens are there, therefore we have to multiply with 3. And what about the overall charge? Because there is one negative charge on the, as the negative charge is the overall charge here, so that we have to take it as equal to -1. So when we solve this one, we are getting like this. Therefore x is equal, x minus 6 is equal to -1. So what will be the x? X is equal to how much? That is -1, and this -6 will go on this side, so it will become +6, that is +5. So +5 is the oxidation state of Cl in this compound. So the oxidation state of Cl, we have find it out, that is x. So what is the oxidation state, or the oxidation number is +5. When we take an example of a dichromate ion, that is Cr2O7 negative, here we need to find out the oxidation state of Cr, that we have taken as x here. And what is the oxidation state of oxygen? That is -2. So how we find it out, this one? That is 2 into x, because there are two number of in Cr2O7 negative, we need to find out the oxidation number for Cr, that we are keeping as x here, and the oxidation number for the oxygen, that is -2. And what is the overall charge here? That is -2 is the overall charge. So when we write this one, how we write here? That is x, 2 Cr are there, therefore 2x, 2 into x, plus here -2 is the individual charge in oxygen, and there are 7 oxygen, so -2 into 7, that is equal to -2, because -2 is the overall charge here. So that is 2x minus 14 is equal to -2. So when you solve this equation, what you will be getting, the value of x is equal to +6. So the oxidation state for Cr in this is +6. Next, when we do the oxidation state here, In such type of compounds, what you need to do here, because there are more than one number of hydrogen, and better you write this type of compound in this way, that is carbon, and here it is total 4 hydrogen and there is a single oxygen. So here we need to find out the oxidation state for carbon, that you can keep it as X, and for H it is +1 and for O it is -2. So here you need to do in this way, because there are 3 different elements are there. So how you do this one, that is X, because there is only single carbon here, therefore X plus, because 4 number of hydrogen are there, and what is the individual charge, +1, that is 1 into 4, that is equal to 4. Next, what is the charge on the oxygen, that is -2. -2 is the charge and only single oxygen is there, therefore -2. And what is the overall charge, that is equal to 0. So in this way, when you solve the value of X, what you will be getting, the X is equal to, that is here 4 is the here it is 4 and it is -2. So 4 minus 2, that is equal to +2. When you take it on the other side, you will be getting -2. So the oxidation state of carbon here is -2. Similarly, you can do this example, that is glucose. You need to find out the oxidation number for carbon here, that you keep it as X, and hydrogen, the charge is +1, for oxygen it is -2, according to the rule which we have learned. So all of you do this example by your own and find it out what is the value of X here. So in this video we have learnt about the oxidation number, and it is very most important point, and we are going to discuss the redox reaction on the basis of oxidation number. So you'll be trying some of the examples by your own, so that it will be easy for doing the redox reactions. So in the next video we'll be discussing about the redox reaction on the basis of the oxidation number. This is all about this video. Have a nice day.